Hello everyone and welcome back to this next lecture. So in the previous lecture I had provided a basic overview of the course and why I chose the microchip microcontroller and what you can expect from this course. Now in this lecture rather, I will go into the details of what you as a student can expect from this course, why you should take this course, and under what conditions you might want to take this course and go deep into this subject. And of course, I will also describe certain cases where you might not want to take this course. Because as I said, for certain types of people, this course might be a waste of time. So, let's get started with this particular lecture. Now, the most important thing you must remember when you're taking this course is that this PIC32CM-MC microcontroller that is provided by Microchip is not used in academia. I have done my master's, I have done my PhD, and I was also a postdoctoral fellow. And during all those years, I never used a microchip microcontroller. Because a microchip microcontroller is typically used in industry, and specifically in industrial domains where, as I said, cutting cost is important. So if you are looking to do a master's or a PhD, or you want to use a microcontroller for your own academic project, like doing a master's, a PhD, or any other R&D project, then you probably will not be using the PIC32CM-MC microcontroller. Therefore, this course is not for you, right? This course is specifically for those engineers who are looking to enter power electronics industry. Because this microcontroller is used in the industrial applications where, as I said, consumer electronics, the cost is extremely important. In those particular applications, wherever we design power supplies or any other advanced application in a consumer product, in that case, these kind of microcontrollers are more popular than the microcontrollers which are used in academia. Because academia and R&D are mainly to serve high-end applications where the researchers do not wish to spend their time on low-level firmware programming, but rather would focus on implementing high-end research. That is high-end advanced controllers, signal processing, and other applications, rather than just writing firmware code. So therefore, this course is specifically for engineering students who are looking to enter the power electronics industry. And therefore, if you are looking either as an undergraduate or as a master's student or even as a PhD student, if you are looking for your first job in the power electronics industry, then I would strongly recommend that you take this course. Because this course will prepare you for programming low-cost microcontrollers. And I hope that I can make several other courses in the future by other microcontroller manufacturers such as STM32 and also Infineon. But for now, I want to start with this particular microcontroller, as this is a microcontroller which I have used in the past. Now, as I already say, if you are a young engineer about to enter industry, or you are already in industry and you are looking to increase your skill set, then the ability to program a vast range of low-cost microcontrollers will improve your demand as a resource. Because the more microcontrollers that you have a knowledge of, the greater will be your demand in the industry as a power electronics engineer. Now, the reason why this is the case is, as I already said, in industry, firmware in most cases is developed using either C, C++, Verilog, VHDL, and sometimes the entire firmware is written as an assembly language. It all depends on the application, right? Very rarely will you see graphical user interface based softwares in industry. And the reasons are several, such as, for example, the cost associated with maintaining license for many of these software. For example, the licenses for many of the C programming based or even the Verilog and VHDL based are much cheaper, and therefore industry usually prefers developing firmware with C, C++ or sometimes even assembly language. Verilog and VHDL are more applicable to FPGAs rather than DSP based microcontrollers. Now, in this course, you will learn how to program the PIC32CM-MC microcontroller using C programming. So this is extremely important. If you are looking for something which is just simple, just to get a simple way to program a microcontroller, then in that case, this course is not for you. This course is if you want to understand how you can use C programming to program your PIC32CM-MC microcontroller. And the reason I say this is that programming this particular microcontroller is quite challenging. Therefore, if you're looking for an easy way to program your microcontroller, this course is not for you. In this course, we are going to go deep into C programming, deep into the actual registers and configurations of the microcontroller and how they can be implemented using firmware written in C program. So, I would still not consider this course as an advanced course because this course deals with how to use the microcontroller and how to use some of the peripherals, right? That's all it is. We are not going to be implementing any advanced control or advanced signal processing or considering any real power electronics applications because those are specific courses which I hope to create in the future. But for now, I just want to teach how microcontrollers can be programmed for young engineers so that they can get ready for industry jobs. So this course will focus specifically on power electronics applications and those peripherals which are needed for basic power electronics applications. And this is an important distinction which I would like to stress on. Most of the courses that you will find on programming microcontrollers will not talk about power electronics. They are usually for communication or for robotics or for industry of things or Internet of Things, IoT. These are the usual applications for microcontrollers that you will find online. And that is the reason why I create these courses, because I feel that for power electronics, there is a huge shortage of learning material. And I do know, and I personally experienced this, because when I was a power electronics engineer and I was learning how to program microcontrollers, I had hardly any help. All I could do was read the documentation and post on the forums. This is the only help that I had. And that is the reason why I've created these courses, because it is extremely important that young engineers have enough resources so that they can learn different microcontroller families so that they can get ready for their industry jobs. Now, it is also important to remember that almost every application now uses advanced features like Wi-Fi or Bluetooth. So for example, if you are building even let's say for example a home UPS, now your UPS such as your home inverter is going to have features like Wi-Fi or Bluetooth, and you can connect to it using your mobile app and all these things. However, in this course we will not be dealing with these aspects. In this course we will be dealing with only those peripherals which are necessary for implementing control algorithms. That is all that we are doing, the bare necessary for you as a power electronics engineer to implement your projects using microcontrollers for hardware. This is what this course is all about. Now, though I'm talking about control and implementation of control, in this course I will not be dealing with any control algorithms. For example, I will not be describing how you can use microcontrollers to implement a current loop or a voltage loop, or how you can control a buck converter or a boost converter or a UPS. The reason is because control is a very vast domain and every control is specific to the application. For example, the control of a buck converter will be totally different than the control of a UPS. And therefore, it is important that when we describe control, we also describe the application, which is not possible in this course because this course is about microcontroller programming. However, every aspect of microcontroller programming will be referenced with respect to control implementation. So for example, whenever I describe a particular peripheral, I will say the reason why we are doing this is because in power electronics applications, this particular action. And to perform this particular action, we need this peripheral to behave in such a manner. So this kind of reference is what I'll be providing throughout this course. So now, to use a microcontroller in power electronics applications, there are a few basic peripherals that we need. So for example, we need digital output pins, We need pulse width modulation for providing gating pulses because in most cases we use converter modules, and those converter modules have inbuilt gate drivers which need only gating pulses, and the gate drivers will actually turn on and turn off the power devices. We also need timers because remember, when we are implementing digital control, it is extremely important that we maintain a specific time interval between samples. And finally, when we implement control, it is important that we have analog inputs that accept measured signals so that we can then close the loop and implement closed loop control. So all this will be described, these peripherals will all be described in this course. So if you are looking for a course that teaches you how to do all this, then this course is for you. If you are looking for a course that teaches something else, then my suggestion is this course is not really for you and you should not take this course. The next thing is that not only will we be describing the peripherals in theory, that is, I will be showing you a bit of architecture and also why certain things happen the way they are, and I will be describing certain registers and also how those registers need to be configured so that the peripheral behaves in a certain manner. But besides this, we'll be actually having live coding sessions. So for example, I will be talking about how we can use example projects provided by Microchip in their GitHub repository and how you can understand those projects, how to interpret them, and how you can then write your own projects using these code examples, making modifications as and how you feel necessary. And finally, we'll be performing basic experiments where I'll be showing the kit and I'll be showing you how this kit is connected to a host computer and how we'll be programming the microcontroller to take certain actions, and we'll be seeing these results visually. For example, I'll be showing you how you can flash LEDs using your microcontroller kit. I'll be also showing you how you can generate waveforms on your oscilloscope using your microcontroller kit. So, in this course, I'll be describing to you how you can set up a basic home lab for just around $150 so that students who are learning to prepare for job interviews can take this course and set up a home lab and learn from it. If you already have access to lab facilities, then all you need is an evaluation kit, which is just $60. So in this course, there will be projects and experiments for each and every peripheral that we describe. So for example, when I take a particular peripheral, such as let's say the PWM module, in that case, I'll be describing not only the theory and architecture, but we'll be creating a project. And this project will have a live coding session where we will build up the actual project, we will write the code, we will create the files, and also finally, there will be an experiment where we will observe waveforms on an oscilloscope and examine how they can be changed. So therefore, this course will provide students with hands-on experience on programming the microcontroller and also understanding how you can use the microcontroller to actually implement control and observe results on the external pins. So this course will also describe how to understand examples projects from the Microchip GitHub page. Now, as I already said, Microchip maintains a GitHub page where they have a number of different projects, and I will describe how you can actually find a project for a microcontroller family which is very close to our own and how we can use those projects as starter projects for creating our own. Now, this is a very important exercise for the simple reason that when you are working in industry, quite often you will not have to start from scratch, but rather you'll be working on already existing projects. For example, other engineers might already have created those projects and therefore the code might already exist. Your job is to interpret the code and to be able to make changes to it, and therefore understanding example projects is a very important skill for a firmware engineer. So the purpose of this lecture was to describe what this course is all about. And as you can see, this course is a detailed course which has been created for young engineers to get ready for industry jobs. If you are looking for a course to quickly generate some results for your projects, then this course is not for you. I would recommend you to look for another course to program your microcontrollers. Moreover, if you are looking for a project which is an academic project, that is, you are a master's or a PhD student or you're working in R&D, then in that case this course is also not meant for you, because as I said, this is a tough microcontroller to actually program, and there are much simpler options available, such as other programs, other microcontrollers from Texas Instruments or from DSpace or many others. And these are very popular in industry for the simple reason that they are very easy to program and they are very easy for R&D engineers to be able to implement advanced control and signal processing. But however, if you are looking for an industry job and you are looking to prepare yourself for industry, then this course is for you. And this is the purpose behind this lecture, to describe what you can expect from this course and who should take this course. And I hope this is clear to you. If any of this, if you still have any questions or if you have any other doubts, feel free to post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture, where we will describe the requirements for this course, and that it also implies the hardware requirements and the components that need to be purchased. So, if you have any doubts, I'll be happy to hear from you. Otherwise, I'll see you in the next lecture. Thank you so much and goodbye for now.